Kyriakos Porphyrakis, and I'm the academic founder of Designer Carbon Materials, as Lucius mentioned. I've got about 20 years experience in carbon nanomaterials, and most of it I spent at the University of Oxford. For the last year or so, I have moved to University of Greenwich, where I accepted a position of a chair of materials and chemical engineering. And the molecules we're making, these round spherical molecules made out of carbon, they're called fullerenes, and we can put things inside them. And this makes them called the Nichidra fullerenes, and they got extra functionality because of that. And the company was spun out in 2014 from the University of Oxford with Oxford Technology help. I'm going to talk about three main applications we've been working: atomic clocks, biosensors, and filtration. Let's start with atomic clock. These molecules, if we put a nitrogen atom inside the fullerene molecule, it's got very precise transitions. And some of these transitions are insensitive to magnetic field. Therefore, they could be used as a resonant frequency standard. And that's the idea of using it as an atomic clock. And to bear in mind, atomic clocks are very power hungry and they need vacuum. These molecules can be used at room temperature. As you can see here in the graph we published recently, this transition at 38 megahertz is insensitive to magnetic field noise fluctuations, which means it can be used as a resonant frequency, which that's the important thing for any clock transition. So NHC60 has got this clock transition, and furthermore, we can improve it, the signal-to-noise ratio even further to improve the performance. We have been working with our colleagues in the US Locator X to try to miniaturize this and bring it to the market. And we expect this to be quite a disruptive thing. It will affect GPS, tracking people, packages, etc. So it's a very, very, very big opportunity and a massive market. And hopefully in the next 2 years, you'll see a product like that in the market for portable devices where people can carry their atomic clocks on mobile phones, on chip scale devices. And that will change a number of technologies, quite fundamentally. The second area of interest is biosensors. These molecules, because they're paramagnetic, they can detect other paramagnetic species around them, such as oxygen, for example. And it's quite important this for tumors because tumor cells consume oxygen in a different way than healthy tissue. So therefore, it's very important to detect the oxygen. So therefore, we have developed this quantum nanosensor, effectively, this molecular sensor that can detect the presence of oxygen. The progress we have made so far, we have achieved two world firsts. First of all, we have made NHC60 water soluble. We have made this fullerene molecule with a nitrogen spin signal inside it water soluble, and that's the first time that this has ever been made. At the same time, we keep the properties of the NHC60, and that was published in ChemCom. It made the cover of ChemCom, as you can see. Important result. And secondly, with the University of Denver in Colorado, we have been working, and we can show, indeed, with the increasing oxygen concentration, we can increase the line width of the material of the NHC60, therefore, we can detect it. So that's the first time that anybody has detected oxygen presence by another molecular system like that. And at this stage, this is in vitro, outside the body, but the molecule is water soluble. It could be inserted in the body. So when it visits in the future, to have like this molecule sent down to the body to detect oxygen. And this is a massive market as well. It's expected to grow over $1 billion. And the third market where we have penetrated is water filters. We have developed a patent for using these molecules, not just to create filters. We're combining fullerenes and carbon nanotubes or graphene, carbon nanomaterials. First of all, they make a nice mesh, which means with a very small pore size, so we can stop any impurities going through the water system. And secondly, these systems do not react with water. They're quite stable in water. Therefore, they don't go into the water that is to be consumed by the human beings. And more importantly, we can shine light. We can shine UV light on this technology. Very simple, just a UV LED UV light would do. And we can kill pathogens and microorganisms, bacteria, viruses. Even COVID-19, for that matter, can also be killed by UV light. And it's very versatile, this technology. We can use it for small portable filters, as you may be aware, like those Brita portable filters that are outside in the market already, all the way to big containers for water purification systems and so on. The the water filtration market is going to grow to expected to grow about $60 billion by 2025. So this is indeed like a massive opportunity as well. So these are the three, this is the type of material we have made. This is the fullerenes and the carbon nanotubes. They contain the pyrene groups, and these are the ones that activate the reactive oxygen species that kill pathogens. And we're working with designers to try to make a prototype device, to test a prototype device. So far, we have been selling these materials. As you can see, we have sold small amounts of materials, but at very high prices. They've got very high valuation. So this NHC60, the nitrogen contained inside the C60 molecule, the fullerene molecule, as I said at the beginning, is a very, very valuable material. In fact, it's considered to be one of the most valuable materials in the world, only second to antimatter at the moment. And the reason for that is all of this potential that I mentioned previously. And we have been selling these materials gradually over the past few years. And as you can see, like about a gram of these molecules, which only contains a small fraction of filled fullerene molecules, is on the order of 80,000 pounds and so on. This shows you like our track record of the sales. As you can see, our sales have been increasing since the company was founded in 2014, which is a good thing, and we're hoping for more sales to come. We have been hit a bit by the pandemic because of the closing of the labs for the last, nearly a year and so on, because we work out of university labs and so on. However, we're hoping that as things will come into an end, operations like that will pick up again. So what we're seeking at this round today is we want to take it to the next level. We're setting up to 150,000 pounds, and this will be used mainly to hire a person full-time to work with me on the production of these materials for the next 1 or 2 years, on backlog of orders that exist already, and also for the new ones that we're expecting to achieve, and also to cover the overheads of the company for fees, patent costs, etc. And finally, have 40,000 pounds or so to go for an Innovate UK Smart Grant Award in order to be able to get 130,000 pounds worth of award in order to improve our infrastructure further and work on the technology of the water filtration on the development of it. The projected revenue is we're hoping for we're expecting for the first couple of years to make sales for about 50,000 pounds worth of materials. So far, with the backlog of sales already placed and the ones that we're in discussion as we speak. So in the next few days, we're expecting more sales, and the ones that we are hoping to get with higher purity materials, as these technologies that I presented at the beginning become more and more mature, higher purity materials will be required to achieve the targets, and therefore we're expecting more to come. And if all goes well, by year 3, we should be able to go like a 10-fold increase in the sales of these materials. Just to add a couple of more things, where, as I said at the beginning, I spent like 18 years of my life at the University of Oxford, where I was heading the lab of carbon materials. And for the last year or so, I have moved to Greenwich in London. And I'm going to also bringing in my research group a postdoctoral research assistant from my own research funding that will be working on the development of the water filtration on the oximetry sensors even further, in collaboration with the University of Denver in Colorado. And also, since from March 2021, I'll be the new director of research at the University of Greenwich at the School of Engineering, which means that we also already have got a promise to expand our lab facilities even further and make it more modern. And I'm leading together a consortium. I'm putting a bid for a strategic grant equipment from EPSRC for £2 million that we're hoping, if successful, will create this Center for Nanomaterials Research at the University of Greenwich, which again, it will open up more commercialization opportunities. It will bring other companies and the universities and academic institutions and expand our reach even further. This is our cap table. It's pretty simple at the moment. We've got the majority shareholders, the University of Oxford, and then we've got the academic founder, myself, and also Oxford Technology, and some private investment that we raised a couple of years ago. So this is our market reach at the moment. We're working in this 2-tier levels system right now. Academic institutions, we have sold materials to different academic institutions around the world, and companies that work to bring these kind of technologies into commercialization. Like, as I said, the most important collaborator is Locator X in the US, where we're working with them closely to miniaturize the atomic clock in order to bring it to the market. Once we do that, then we're going to go to the third tier, which is like a big, like commercial scaled up production. And we expect that then the demand for these materials will soar. In terms of competition, there are a couple of companies in the US that sell some types of endohedral furnaces, but nobody sells the NHC60 types of molecules like we sell, and also with the purity that we can achieve. Nobody can do that. And we're truly world leaders when it comes to NHC60 in the molecule that we talked about earlier. That's it from me. I know I've only got like about 10 minutes or so to present you. So thank you very much for your attention. And I just put up our website and our email address if you want to talk to us further. I'm happy to answer any questions.